Okay, so let's take a look at some alkene reactions. And the first one we want to look at today is the alkene reaction with hydrogen bromide. And of course, for these two starting reagents, the alkene is the nucleophile. That's the chemical which is electron enriched, and it's going to use those electrons in the double bond to make a new chemical bond to another nucleus. That's where we get nucleophile from, nucleus lover. And for the hydrogen bromide, its role in this reaction is the electrophile. It's the electron lover. It's going to accept electrons from the nucleophile. And most of our reactions and reaction steps can be broken down into these basic ideas. Nucleophiles making new chemical bonds to electrophiles. So the nucleophile uses those pi electrons in the bond, stretches out to make a new bond to the hydrogen. The reaction follows Markovnikov's rule, and the side of the bond which has more hydrogen currently, the N carbon, is the side that gets this hydrogen when it attaches. Markovnikov's rule, the rich get richer. So as this double bond swings open, the hydrogen is going to attach on this side. Of course, when that new bond forms, the existing hydrogen to bromine bond has to break, and we produce that carbocation as our intermediate. Now that the pi bond is broken, the electrons have been torn away from that central carbon. It has an incomplete octet and a positive charge. Of course, having picked up the hydrogen from hydrogen bromide when the bond breaks, we've got in solution a bromide ion kicking around. The alkane is the carbocation, the electron needy part of the reaction, and the bromide, now with a negative charge, is the nucleophile, providing the electrons in the second part of the reaction, which is the faster reaction step. The slow part is the first part of the reaction as we produce the carbocation. Because the first half is the slow step, of course that's the rate determining step. So that bromide comes in as a nucleophile, attacking the carbocation, which is also the electrophile in the second step, and we produce that final product, that hydrogen halide 1,2 addition product, and our reaction is complete.